Spacecraft mock-ups crash. Airplane models spin. Space-age materials shatter. All in the name of research to make air and space travel safer and more efficient. That's the mission of NASA's Langley Research Center, engineering a better future. NASA Langley sits on 800 acres in Hampton, Virginia. The United States' first civilian aerospace laboratory, it operates some 25 wind tunnels and simulators and employs more than 3,000 workers. Since the research center was established in 1917, its people and facilities have left their mark on everything that flies, from the shape of military aircraft, to the cockpits of passenger jets, to the materials of spaceships. Now Langley researchers are working on technologies to help America rocket past low Earth orbit, to the Moon, Mars, and beyond.
3, 2, 1, release.
Drop tests at Langley are helping to shape NASA's next space capsules. It's back to the future for the gantry, which started its life in the 1960s as the place where Neil Armstrong and other astronauts learned to walk on the moon. When Americans walk on the moon again, it will again be in part because of NASA Langley. The employees' knowledge of guidance, navigation, and control, and entry, descent, and landing will be incorporated into the Orion crew vehicle design. Some of those skills have already led to the success of robotic Mars missions.
NASA Langley's expertise is in atmospheric flight. So what that means is basically whenever we have a spacecraft or a space shuttle or an airplane fly through an atmosphere, we have expertise to understand how it would fly.
That includes how something would fly over another planet. Researchers in Hampton are using wind tunnels and other facilities to design the first aircraft that may fly over Mars. The Mars Airplane Project wants to survey 300 miles of the red planet from less than a mile above the surface. That's much more area covered than the rovers, much closer than the orbiters. Wind tunnels continue to be a critical tool for better understanding more traditional aeronautics too, whether it's hypersonic, 5 times the speed of sound, or subsonic, the speeds airliners fly. Langley researchers are working with industry to create more efficient aircraft designs, like a blended wing body. They're also developing technologies to make existing planes quieter and safer, often using airline pilots to test their theories.
It's a real benefit to the flying public having NASA be involved, having NASA initiate these type of experiment and development. We otherwise would be years in getting this type of equipment to the airlines, both for safety and for improved reliability.
Langley efforts have already gotten life-saving equipment onto passenger jets. NASA researchers developed special radar that can detect wind shear, deadly microbursts associated with thunderstorms. That radar is now standard on new U.S. airliners and may soon be upgraded to spot atmospheric turbulence because of Langley research. And when rare airline accidents do happen, federal aviation agencies look to Langley's decades of experience in aerospace materials and structures to help in crash investigations. That expertise also paid off when NASA was working to safely return the space shuttle to flight. Researchers in Hampton analyzed foam, tile, and wing leading-edge materials. They also developed a camera system that can examine the shuttle's wings for flaws that can't be seen on the surface. Using instruments to see things that aren't easily visible is another Langley specialty, especially when studying the atmosphere.
We have ignition, and we have liftoff of NASA's Calypso.
Scientists in Hampton developed the Calypso instrument that recently launched to study clouds and airborne particles. The answers that satellite and other remote sensors provide are helping researchers and meteorologists better understand weather and climate change. The Earth, Moon, Mars, and beyond. That's what work is all about at NASA's Langley Research Center, engineering a better future.